Hey guys, welcome back, and we're going to be starting chapter 6, and 6.1 is angles and radian measure. And for this one, I couldn't find a way to split it up nicely between two things, so I'm just going to go all in one, and you can split it up however you like over the course of a couple days. But so for the thing slash one, I have what is the circumference of the unit circle in terms of radius? Um, and in terms of radius, kind of doesn't even really matter, right? So we have a unit circle, and it's kind of horribly drawn at the center, but you guys get the point. What is the radius of this unit circle? It's supposed to be 1, right? And what is the area of a circle, right? Or what is the circumference, right? The circumference is pi times diameter, or 2 pi r. Well, if the radius is just 1, then isn't it just 2 pi? So the circumference of a unit circle is just 2 pi, and that's where we define this thing called radians. So radians is just another way to measure angles, other than degrees. So it's like a different, it's like meters versus feet, right? It's just a different way to measure angles. But radians can be really nice in some scenarios, which is why we have two different measurements. It's not for no reason. Um, so it's a different unit to measure angles. It's based on the circumference of a unit circle or the length of an arc. So this is why a full revolution is 2 pi radians. And when we see radians is just like anything. It's like degrees. It's like inches, feet, right? It's a measure. Um, so 360 degrees equals 2 pi radians. Half of that, 180 degrees, is going to be pi radians. And 90 degrees is going to be pi half radians. So what is 1 radian equal to? Well, we kind of have this right here, right? 180 degrees equals pi radians. So how am I going to change pi to 1, right? Because that's what I want. I want 1 radian. Well, I'm going to divide by pi. And so that actually gets me that 1 radian equals 180 degrees divided by pi. Or 100, I should write 180 divided by pi degrees. And you might want to write that down, and you'll probably want to write this next one down too. So what is 1 degree? Well, 1 degree, wouldn't we, if we look at this, right? 1 radian equals 180 divided by pi degrees. To make that side 1, couldn't I divide by 180 divided by pi, right? Something divided by itself is 1. And when you divide by a fraction, you actually multiply by a reciprocal, right? So let's do 1 times the reciprocal pi over 180. So 1 degree equals pi over 180 radians. And you might want to write that down as well. So with that said, change 330 degrees to radian measure in terms of pi. Well, we just said that one. Where am I at? Wait, which one was that for? Change 330 degrees to radians. Well, we just said that 1 degree, right? We just said that 1 degree equals pi over 180 radians, right? So, um, so to do 330 degrees, we're going to multiply that by pi over 180. And when we do that, 330 and divide by 180, we would simplify that to be 11 on top, 11 pi, and 6 would be on the bottom. And if you can't see that right away, just reduce your fractions until you get there. And now it says change 2 pi over 3 radians to degree measure. And this is the opposite, right? So now we have 2 pi all over 3, and now we want to times it by 180 divided by pi. And this makes sense, right? Because these pi's are going to cancel. And that's what we want in degrees, right? We don't have pi's in degrees usually. And then we can do 180 divided by 3. So 180 divided by 3 is going to be, I don't know why I'm looking right now, 60. And 60 times 2 is going to be 120 degrees. So that is that one. And now here's this stuff in your textbook of radians and degrees put together, right? And we can see the ones we just found, 11 pi over 6 is 330 degrees. And what was the other one we just had? 120 degrees was 2 pi thirds. Now, you can feel free to write these down or copy these down or take a picture, put them somewhere. But for me, what I would do is I would remember basically just these first 4, that one, and don't even need that one. So right, because 0 degrees is 0 radians, so that's fine, right? That and I think we know that 360 is 2 pi, so then I think 180 being pi is okay. And so what's really important is if 30 is pi over 6, you memorize that, and 45 is pi over 4, and 30 is pi thirds. That's good. Those are really the 3 that you have to remember, because it's easy to know that 2 pi is 1 revolution, so half of that is 180, half of that is 90, which gives you pi halves. And then to get the 270 being 3 pi halves, you add pi halves to pi, right? 90 to 180, and you get 3 pi halves. So it's really these first 3, and I think that will help us a lot. So evaluate cosine of 4 pi thirds. Now, when I see 4 pi thirds, I'm trying to find out where it's at. So I'm thinking in terms of these quadrants. I know that 180 degrees is pi, right? And it's more than pi, and I know this is 3 pi halves. The 4 thirds isn't really bigger than 3 halves. So I know it's going to be in this third quadrant somewhere. And to do that, when I think of pi, right? Pi is going to be 3 pi all over 3, right? I'm just matching the denominators there. So really what I've done is I've added pi over 3, right? To get 4 pi thirds. So really, I've gone here and then I've added pi over 3. And then what I do with that information, now this is where memorizing like pi thirds comes into play. So if we go back here and we memorize pi thirds, we will see that pi thirds is 60 degrees. And so really what we know is we know that this is 60 degrees. And then from there, we can make our triangles, right? Our 30, 60, 90, 1, square root 3, 2. And you might be comfortable with these by now, right? The cosine of 60 degrees, I'm not even going to look at my triangle. I'm just putting it there in case you forgot it. But if you're comfortable with this by now, that's totally okay. I know that the cosine of 60 degrees or cosine of pi thirds, same thing, is 60 degrees, right? But I know that we are in this third quadrant, right? So I know that, sorry, that's wrong. I know that cosine of pi thirds or 60 degrees is 1/2. That's the ratio, right? It's 1/2. But I know, right? I know A, S, T, C, so cosine is negative there. So it's actually, so when we do cosine of 4 pi thirds, which is the actual angle, right? That's going to be negative 1/2. Now, the length of an arc S is equal to radius times theta in radians. And why is that? So if you think about it, the length of an arc of a circle, let's think of the whole diameter, right? whole diameter is, or the whole circumference is 2 pi r, right? And so it would make sense that, let's say if we did half of a circle, right? That would be 180 degrees, right? Divide by 360. So the amount in 360 degrees, 180 divided by 360, 1/2 would be 1/2 the circumference, right? So the angle has a direct correlation to the length of arc, right? And so it would make sense that instead of, if we're in radians, instead of dividing by 360, 2 pi is a full revolution, and we said theta, right? The angle measure divided by 2 pi radians is how much angle you have out of a circle, and then you times that by 2 pi r, right? The 2 pi's are going to cancel, and this would be your length. And if you have trouble seeing that, it doesn't really matter. You just really should probably, just write that down and make sure you have that. So example 3, given a central angle of 128 degrees, find the length of its intersected arc. And when we're talking about this, we're in radians, right? And so to get radians, we're gonna multiply by pi over 180, and you would simplify that, and you would get 32 pi over 45. Right? And so now we just use our equation. The length equals 32 pi divided by 45 times the radius, which it tells us is 5 centimeters, and 45 and 5, that'll change to a 9 on the bottom, right? And then 32 pi divided by 9. This one is just a number cruncher, 32, and then you should have a pi button. Otherwise, you can use 3.1415 divided by 9, and you get about 11.17. And so a sector of a circle is an area bounded by a central angle in the intercepted arc, or a slice of pizza, right? So if we have this would be a sector. That's a sector. And the area equals 1/2 radius squared times theta. And it's, the same thing. Let's think of an area of a normal circle. The area or of an entire circle would be pi times radius squared, right? But now now it's just like a part of the circle, right? So it would actually be multiplied by the angle, right? This central angle here, divided by 2 pi is the full revolution, right? So the ratio. And then you'll notice that pi and pi cancel, and then you're left with theta r squared all over 2, which just rewritten is 1/2 r squared theta, right? And so that's how we get that. And so example 5, find the area of a sector if the central angle measures 5 pi over 6 radians, and the radius of the circle is 16 centimeters, round to the nearest tenth. So we just had a equals 1/2 theta r squared, right? Or they put r squared first, doesn't really matter. And so area equals 1/2 times theta. It gave us is 5 pi all over 6 times 16 squared. And again, that's just a number crunch. And when you do that, you should get about 335.1. And then we are technically in centimeters. And so there we go. And so I know I went fast, but this section is pretty quick. And I know it might be weird to work with radians at first, but I think we will just get more and more used to it. And I know I went fast, and these examples are just kind of like whoop. But really, I think this is the big thing here is getting used to these um, and conversions, because those are really the biggest things in this section.